What I want to do here is I want to look at several examples of working with proof by contrapositive statements. I'm going to show you a few examples. I want you to then pause it, have a go at them and come back and check what you've done with the working I'm going to present here. So here's your questions. Firstly, prove that if n squared is even, then n is even. Secondly, prove that if n to the power of 5 is odd, then n is odd. Thirdly, if a and b are both odd or even, then a squared plus b squared is even. And then the fourth and final one is if a is irrational, then 1 over a is 2. So pause this video now, have a go at them and come back and check. So the first statement was prove that if n squared is even, then n is even. So remember, the first thing we have to do is build up that contrapositive statement. And again, it's turning the statement of if P then Q into the format of if not Q then not P. Well, the if P then Q is if this is even, then this is even. So to turn that round, what we'll do is we'll turn it and say if n is odd, then n squared is odd. So that completely flips the entire statement on its head and approaches it from a different angle, but the logic is still the same. The logic still matches up with what we want. So now we just have to do the work. Well, remember, n is odd, so what we're going to do is let n be a number of the format 2k plus 1. You could also use 2k minus 1 as a format for an odd number. Both should give you the same outcome at the end. So what that then means is that n squared is equal to the 2k plus 1 squared. So that's going to be 4k squared plus 4k plus 1. Now, if I just focus on this first part here, the 4k squared plus 4k, there's common factors in there. There's a 4, there's a k. However, if I just take out a 2, so I have 2 times, and then in here I'd have 2k squared plus 2k, then plus 1, I'll have 2 times something as this first part. Now what you've got to remember then is that that's 2 times something which will always be even. So I'm going to take this bit here and I'm just going to let it be represented by the letter m. That means I've got something that's of the format 2m plus 1. Well, if we go back and compare that with our original choice for n, that is also the format of an odd number. So what I can say is fine, therefore the contrapositive is true. Yeah. If n is odd, then n squared is odd. What that then means is the original statement is also true. So I've proven that statement by looking at the contrapositive, negating both parts, keeping the logic the same, and working it through using a standard format for an odd number. The second statement I said to you to work with is prove that if n to the power of 5 is odd, then n is odd. Again, your first step in anything like this that involves the contrapositive is to build that statement up. Build that contrapositive statement up so you've got something to work with. Again, we're going from if P then Q to if not Q then not P. So in this statement, it's essentially an if this then that. So we'll revert it and say fine. If n is even, so that's the not Q part, then n to the power of 5 is even as well. So there you go, I've built up my contrapositive statement. If n is even, then n to the power of 5 is even as well. So what I now do is I want to go and have a look at this and how I can work with it. So I'm going to let n equal something in the format of 2k. 2k is always going to be an even number, so let's work with that. What that then means is I'm going to do n to the power of 5, which is going to be 2k all to the power of 5. That's going to be the equivalent of me doing 2 to the power of 5 times k to the power of 5. Well, if I factor out one of these 2's here and keep it as 2, and I put the rest of it in a bracket, that'll essentially be 2 to the power of 4, which is 16, and then k to the power of 5. So again, in this case, I've got 2 times something. And if I let that something, again, be represented by m, it's going to take the format of 2m. And again, if I go back to my original statement for n, it is the exact same format, which was representing an even number. So fine. What that then means is my contrapositive is true. So because of that, and following that logic, my original statement is also true. So I've used the contrapositive, the logic that follows through, I have proven what I originally wanted to prove by looking at it from that perspective. This one here, so the statement says, if a and b are both odd or even, then a squared plus b squared is even. Again, usual drill with a contrapositive proof. We have to build up the contrapositive statement. Now, the last couple have been quite nice and easy, taking formats of even and odd numbers for single things. This one here is the if p then q, so if a plus b are both even or odd, then the q, which is a squared plus b squared, is even. Revert it, flip it, and start to look at it from the other perspective. So in this case, the if not q would be if a squared plus b squared is odd, then, and now we have to look at the if not p part. So if a and b are both odd or even was the original statement, this would be then saying then either a or b is odd. So that means only one of them can be odd, meaning the other one of them has to be even. So let's take two generic numbers a and b in the correct format and let's see how it works. So if a squared plus b squared is odd, it's going to be something of the form 2k plus 1. That's the ultimate goal. Now either a or b is odd. Let's say that a is the even number and b is the odd number. If you chose to go the other way, a or odd, b or even, fine, you still work it, no problem at all. Let's then work it through. So a squared is 2k squared plus, and then the b squared is 2k plus 1 squared. What that's going to give me is then 4k squared plus 4k squared plus 4k plus 1. Again, group like terms together to simplify it down, and I'll get 8k squared plus 4k plus 1. Now, if I look at this, and again I focus on just this first part here, I can take a common factor of 2 out of both of those terms. So I can write it as 2 times 4k squared plus 2k, and then plus a 1. Now that's the same format as 2 times something, which is this part here, that's the something, add 1. Let's let the something be represented by m. It then is 2m plus 1. So it's something that's taking that format of 2m plus 1. Because that's the format it's going to take, it's odd. So because it's odd, my contrapositive statement holds, which means by that logic, my original statement also holds as well. So the contrapositive is true. What that then means is the original is also true. So we've proven it by looking at it from the opposite perspective, whilst maintaining the logic associated with the scenario, by going from if p then q to if not q then not p, just as the contrapositive wants us to do. The last statement was this one. If a is irrational, then 1 over a is 2. So if a is irrational, then 1 over a is irrational as well. So my contrapositive statement for that, we have to look at the types of numbers. So if A is irrational, 1 over A is rational, what that means is that what we have to do is state that if 1 over A is rational, that means is that A is also rational. Now we have to remember what it means to be a rational number. If 1 over A is irrational, then that means that it's of the format B over C. But what we've got to remember is that B and C have no common factors whatsoever. So if that's the case, that's what we're going to work with. So if 1 over A is a rational number, that's the format it's going to be. So if I were to rearrange that, what I'd end up getting is that A times the B over C is equal to 1. So A is equal to C divided by B. Now remember we stated here that B and C have no common factors. That hasn't changed at all, so B and C here still have no common factors. Writing the A then as C over B means it's a rational number as well. So if this one's rational, this one's rational. My contrapositive statement holds, so the contrapositive is true. And what that then means is my original is also true. All that comes through from the logic being maintained by the contrapositive statement and its relationship with the original. Working with contrapositives can be quite straightforward as long as you nail that first statement. Always just ask yourself, the statement is if P then Q. How can I turn that around and make it if not Q then not P? Think of your types of numbers. So in this one we had rational and irrational numbers. Previously we had odd and even numbers. All of this can come into play. Make sure you're aware of how to work with each of those and you're aware of what they mean, and you should have no problem with a concept such as this.